Hello everyone. In this workshop, the main theme is to make the mesh of this model in the ANSYS meshing, and but I will also add the two more things. One is geometry making in space claim, and also very simple sample simulation in Fluent, so that I can show you the flow contours and path lines, vector plots, etc. So first of all, I will start from a new geometry. So you have to create from the file menu. You have to click on click on new and design. So design number 2 is here. You have to close design number 1. Okay, so this is a simple geometry with one rectangular block and two cylindrical bodies on the two sides. So to make it, first of all, I will go to the file menu and space claim options. And from there you have to click on the units and change the length units to the meters. Simply click on OK, and after that we have to go to sketching mode and click on the rectangle. Simple. So dimension I'm going to set is the 5, so put the 5, or on this side maybe it's 3. 3.5, and then press the tab key and we will go to second dimension, and for that put the length as the 5 meters. Okay, so now I will go to the 3D mode by clicking on the end sketch editing, and we are in the design menu and pull command selected. So simply click on the surface and pull it on the upper side so that we can make the 3D geometry, and this is, I think, sufficient. After that we are going to again go to sketch menu, and from here I will choose a circle, and on the top side I will make one circle with some diameter. This value is a very random and it doesn't matter, basically the dimensions doesn't matter here at all. And the second one we are going to create is on the bottom side. Okay, now again go to 3D mode. So on the two sides we have these circles, and we can use the pull command to make the 3D geometry, and this will definitely is going to be cylindrical body. And similarly on the bottom side. Okay, also I want to move this geometry slightly, so select this all here and simply move on the one side like this. So select the arrows, and for example the green arrow is for the x direction, blue is for y direction, and the red one is for z direction. Also we have 3 rotations if you want to rotate the geometry. Okay, so now because the method we are going to use in the ANSYS meshing is the multi-zone meshing, and although it says that the multi-zone mesh does not require any type of geometry decomposition, but if you do that thing, this will be much easier to make the required meshing in the ANSYS meshing. So, but for the sweep meshing, definitely we have to decompose geometry to the very minute details, like we have to create all the blocks ourselves. But in the case of the multi-zone method, we have to create the cylindrical shapes at least. Okay, so I will go and create the 2 planes on top side and the bottom side, and then use a combine command and choose this body and choose this plane. So basically what we did is that we separated the upper cylindrical body from this main body, and similarly you have to go on the bottom side. Now this body is remaining is the rectangular block and cylindrical shape on the bottom side, and choose a plane. That's all. Okay, so you have to click on screen after this process. Okay, and now go to select mode, and what we have to do is that we have to basically hide this body first. Okay, now you have to use the pull command, and pull command will be right now used as extrude tool. So I will pull this geometry up to the and make it no merge, okay, and up to this geometry, this cylindrical, this part here, okay, this plane. And similarly this face will go to create the 3D body and up to this plane. Okay, I will use a combine command, and I will be basically will separate this body into two parts. Then click anywhere, again choose this cylinder and choose the bottom plane and click anywhere. Now you have to display the third body, and you can see one thing, that this body is now overlapping. You can see this is overlapping. So we have to basically remove the extra material which is going to be overlapping here, so that we can make the mesh geometry for the multizone method. So I will use again combine command, and now you have to choose the rectangular block and this body here, okay, and click on the extra body which is created. This is basically extra material which we removed from the rectangular body. So click here, then click anywhere on the screen, and again click on the body and then the cylindrical body here, and remove extra body from here. That's all. Okay, so now you can see that this body has now these shapes in between them, okay. Now you can show all these bodies. And the next thing is that you have to go to the prepare menu, sorry, the workbench menu, and click on the share. So this will basically make a single part out of these 5 bodies. This is same as forming a new part in the design molder. So this will make the connections virtually, and the mesh will be continuous across these bodies. So you have to, for the multi bodies part, you have to make the share topology. So come to the workbench menu and click on the share and click on this tick mark, and this will do all the things by its own, okay. Okay, last thing is definitely is to set the boundary conditions, and before that I want to delete these 2 planes, okay. Go to groups, and in the groups you have to select the, let's say, this surface, and click on create name selection. This is, let's say, this is inlet, and this one will be the wall number 1, and these peripheral surfaces will form the wall number 2. These are random names, and it does not signify anything at all. Thus, just we have the name so that we can identify parts in the meshing or in the Fluent. So we have the inlet, wall 1, wall 2, and wall 3, and the last one is going to be the outlet. Okay, so save your file, and now again go back to the workbench menu and click on ANSYS Workbench 2023 Release 2 from here. And this will open a new workbench file. This takes some time. Okay, now you have to include directly the fluid flow system, or you can use the meshing and Fluent separately. So let's create the meshing app here, and double click here to open the ANSYS meshing. Okay, so now we have this geometry with us. So first of all, we start with clicking on the mesh and make sure that we have the CFD and Fluent selected. And after that, I will be using the method. But before that, I want to hide the one geometry part, that is this block here. So right click here and hide body. Okay. So again, go back to the meshing and select on the method. So for these four bodies, we will use the multizone method. Okay, so then second thing that I'm going to put is the inflation layers. So select all these four bodies. So right click here and select all. And the boundaries I'm going to use are these four boundaries. And let's use the default conditions. Okay. Then I will use a face meshing on these four faces, and this will make the basically map meshing, means that these will look like a OGID in the ICM CFD. So without that, the meshing will be random, like a pave hexas. Okay, random hexas. So with the map meshing, they will be regular geometrical shapes. Okay, so click on generate. So I was talking about this thing. Okay. So one thing that we can do right now, so you can see that the diameter is approximately 1.5. So let's put the first cell height as 0.005. Just try this thing. And if this is okay, then we go with it. If this size is smaller or larger, we will adjust. So I think I would make the size as the 0.01. This seems okay. I would suggest now maybe 0.03 would be better. Okay, this seems better. Okay, so and also you can put the inflation separately, because this is a small body with smaller diameter. You can use them separately. Okay. Now you have to show the last body, which is here. And for this body, I will use another method, that is triangular. Although this is making triangular mesh, but anyhow, I will be enforcing my method tetrahedrons. And also I will use some body sizing. So sizing on this body. And let's make the size as a 0.1 and click on generate. Default size was 0.4, but I am making it to be 0.1. Okay, and then once again we have to now we have to hide these four bodies. I want to enforce the face sizing, so choose the face and sizing, not the face meshing but the sizing. And here I want to force some sizing here. So let's try with the 0.05, and before that we create new mesh. Right click here and click on create generated data. Okay, and then click on generate. Okay, display all the parts. So right click and show all bodies. Okay, let's make this sizing to the 0.08 and again generate. Okay, so this size doesn't make any problem. Okay, if this errors is there, they cannot connect to given boundary elements of the following entities, no problem. You have to clear all the data and generate mesh again. Simple. Okay, last thing that I will be doing here is to create inflation around these cylindrical bodies over here as well. This is may have the good impact. So let's try this thing also. So I will be hiding these 4 bodies again, and click on the mesh and inflation. So this body and these 2 boundaries, and generate. Okay, you can also make this inflation as the smooth transition. This should make the better mesh quality. Okay, so now the mesh is completed, and we have to put the fluent part. So go to the tools here, and from here choose the fluent and put over here. And this requires a mesh update. So either you can right click here and click on the update mesh, or you can go to the meshing app and then click on the update here. Same thing will happen. Okay, close the meshing app and open the setup. This will open the Fluent setup, and you can use the multiple processors, like for example 4, and click on start. If you have the more than 4 cores in your CPU, or more, maybe 2 CPUs like in the workstations, you can use them. So rule of thumb says that for at least for 0.5 million cells, there should be 1 core, and better would be that for the every 0.2 million cells there should be 1 core, and for every 1 million cells around 2 to 4 GB RAM is required. Okay, you can display the mesh like this. And you can also make the some random colors by clicking on the colors and then choose by surface. So for every surface we have the different color. Okay, now let's put the velocity as and also before that I want to choose the water as my working fluid. So click on create edit, and from the Fluent database go there and choose the water liquid, this one, and click on copy, close. And also you have to make sure that in cell zone conditions your working fluid for all these parts, so they should be the fluid. Okay. Okay, now let's set the boundary condition. So I will give for the inlet as 0.1 meter per second. I think this should be sufficient. I didn't calculate any boundary condition for this case, but so I'm just giving the randomly, and click on the close, and then simply initialize. Okay, and also add extra zeros in the residual monitor so that we can have the better convergence, like maybe like this, and click on OK, and then click on the run calculation, and I would suggest go for maybe 200 to 300 iterations should be enough. Okay, now the simulation is completed. It completed the number of iterations. So let's see the results. I will create a one plane, and this is going to be on the center location. So this will be on the constant Z location. So choose a mesh and Z coordinate, and it should be on the center, and click on. Okay, so we just created one plane here, and if you want to see the plane, so that is going to be the over here. Okay, I think we should move this plane to some other location. So go back and in the ANSYS surface, choose the same mesh, then the Z coordinate, and you have to move the slider. So this one should be the proper plane, this one. Okay, so now it is looks like this one. Okay, so you have to now click on the Z coordinate 12, and this is the plane we are looking for. Okay, on this plane I am going to display the contours for pressure and velocity. So first the velocity. So velocity, this is the pressure contours, and then the velocity contours. So you can see that we have the high velocity over here. So let me display the mesh as well. So I'm going to display the inlet. This is inlet is over here. Okay, so it means that this velocity in the bigger pipe was smaller, but when it entered into smaller pipe, its velocity increased. And if you want to see the vector plots, you can display them from here. So there is looks like a lot of flow is going here and there, and also some separation I can see on the corners and also inside the pipe. Okay, now let's display the path lines. So I will click on the path lines from here. Okay, draw the geometry. Okay, colors, make them by the type. Okay, after that you have to go to the view menu and click on the compose. Okay, select every wall one by one, and then you have to do these things, uncheck these options and make the transparency like this. So continue for each and every boundary. So basically when we display the path line, it should be visible from outside as well. So that's why we are making these walls, we want to display them, but also at the same time we want them to be transparent, slightly transparent, not 100% transparent. So okay, like this. And also you can display the sum of parts with the mesh as well. So you can display the edges, and you can also change the colors. Okay, let's make the transparency a little bit lower. If you go there, and and let's change the colors also here. Okay, so that's okay, and also make the overlays so they will always be displayed. Okay, so even by mistake, if you don't select the mesh from here, they still will be displayed. Okay, so I will display the particles or the path lines from the inlet, and I want to skip initially 20 path lines and click on save display. Okay, now we have to remove the path lines, and we want to display more path lines there. Okay, so path scheme, make it true, and then go to also attributes, and from here you can change the line width to the 2 like this. And also you can make the these as a line arrows, and in the attributes keep the line width as a 2 and the scaling factor as a 10 and scale as a spacing factor as a 10 and scale as a 0.1, and then click on save display. Okay, I think we should increase the scaling, the number of the heads, arrow heads. So we have to make the smaller spacing factor. Let's make it 0.2 and make the scale as a 0.2 as well. So 2 and 0.2. Okay, now I want to go to back to the compose menu, and you have to delete the extra geometrical parts there. So don't draw mesh every time. So after this, select them all and delete. Okay, so now again make sure that overlays are enabled, and now click on save display. Okay, so you can see that how the flow is behaving here. So I would suggest that make the path skip to the 4 and spacing factor to the 5 and scale maybe 0.15 and do it again. Okay, remove the first path line and just keep the second path line. So now you can clearly see that how the flow is behaving. And I would suggest that we may remove the one of surfaces which is here. This is, I think this is the wall number 2. So you can remove this one from display. So that's all about this whole workshop. The main idea was to teach you meshing methods.